Hello everyone. Today we will start Measure of Dispersion, a chapter from Statistics. So first is, what is measure of dispersion? Measure of dispersion will give a measure how the whole data are distributed about the central value. When all the sample values are equal, the value of the dispersion will be 0. The wider will be the discrepancy from one observation to another, and the larger will be the dispersion. So some important measure of dispersions are range, quartile deviation, absolute mean deviation, standard deviation, and coefficient of variance. So first is range. Range is defined as the difference between the greatest and the least values. If x max and x min denote the greatest and least sample values of a distribution, its range will be given by range equal to x max minus x min. So the coefficient of range is defined by the ratio x max minus x min divided by x max plus x min. And our data is said to be good data if its range is relatively small. Now one question. Find the range and coefficient of range for the following observation: 20, 10, 37, 50, 90, 58 and 60. So range equal to x max minus x min. So here maximum value is 90 and minimum value is 10. So 90 minus 10, this is 80. And the coefficient of range x max minus x min divided by x max plus x min equal to 90 minus 10 divided by 90 plus 10, and this equal to 80 by 100, that is 0.8. Another question, find the range of the following data where height they are in class interval, we are having the interval, and number of student. So 60 to 62, 63 to 65, 66 to 68, 69 to 71, 72 to 74, and number of students are there. So since the gap is there, so gap means 60 to 62, then one gap 63 to 65, one gap 66 to 68. So gap is there. So first we have to remove the gap. How do you remove the gap? 0.5 less, 0.5 more. So the lower boundary will be 59.5 and the last upper boundary will be 74.5. So therefore range equal to 74.5 minus 59.5, that is 15 inches. Next is our partition value. So before going to the just see, so in our classification we have quartile deviation. So before going to the quartile deviation, we should know about the partition. So first partition is quartile. So here three quartile we have: first quartile, second quartile, third quartile. First quartile is 25%, second quartile means 50%, and third quartile means 75%. So here in the case of group frequency, the general formula will be Qy equal to L plus I n by 4 minus f, divide f into c, where I equal to 1, 2, 3. So here the formula here n by 4, that means here we are dividing by 4 equal parts. For equal parts. So that's why this is 25%, 50% and 75%. So that's why this is 4 divided by 4, n by divided by 4. And the second quartile, this one, the second quartile, that is Q2, which means median. It's also known as second quartile and median. So second quartile, median is same. Next is decile. So decile, that means we are dividing by 10 equal parts, like this, 10 equal parts. So that's why here n by 10. And it is starting from D1, D2, D3 up to D9. So we are finding here 10 equal parts. So that's why here n by 10. So di equal to L plus I into n by 10 minus f, divide f into c, and I equal to 1 to n. Next is percentile. So percentile we will divide by 100 equal parts. In this way 100 equal parts, and the generally denoted by P1, P2 up to 99. So here and the formula will be Pi equal to L plus I n by 100 minus F divide F into C, where I equal to 1 to 90. So we have seen, so if we put I equal to 2, if we put I equal to 2 in quartile, this one, so we will get the formula of median. So that's why here Q2 equal to median, already I told you, Q2 equal to median, that means second quartile equal to median. Same way for this side, if we put n equal to just see here, after here I equal to 1 to n. Okay, so by putting which value we will get the formula of q2. So just see, by putting the value is fifth, that means by putting, go back to the previous slide, by putting I equal to 5 here in this formula, we will get q2. Same way percentile, by putting I equal to 50, we will get Q2. So this is very important line. Second quartile into fifth decile equal to second quartile equal to fifth decile equal to 50th percentile equal to median. Okay, so next note we have. So before going to note, just see here quartile deviation, we are going to find one problem, then we will understand how we will use the note. Okay, so just see the quartile deviation. So quartile deviation means quartile range is q3 minus q1. So already we know that what is q3 and what is q1. Q3 means here third quartile and q1 means first quartile, and the formula is, actual formula is quartile deviation equal to half of q3 minus q1. So here question is, calculate the quartile deviation for the following data. So data are 0 to 40, 41 to 80, 81 to 120, 121 to 160, 161 to 200, 201 to 240, 241 and over. So here gap is there, just see the gap. So we have to remove the gap. So for this, first we have to use class boundary for finding the for removing the gap in the class interval, 0.5 less, 0.5 more. So in this way we can easily remove the gap. Next is frequency. Actually for quartile deviation, what we need q3 and q1, and both are belongs to formula of quartile. Formula of, just see here, quartile. I equal to 1, I equal to 3. So quartile means here which are related in the formula L, F, small f and C. These are related. So F means here cumulative frequency. So that means here what will be your next column? Frequency, that is also given. So only one column we require, that is cumulative frequency. How do you find cumulative frequency? Already I told you several times. So whatever we have, actually cumulative frequency we will use always less than type. Okay, if it is specified in your question paper, go for it, otherwise less than type. So whatever the value is given, we will just put the value 394, 394. Then cross addition, 394 plus 461, 855. 855 plus 391, 1246. So in this way we can continue, and at the end of this you will find 2010 and 2010. That means your calculation is okay. So now what we told you, I told you we have to concentrate on q1 q3. So before going to find q1 q3, first we have to find out q1 q3 class. So how do you find the class? So now for finding class, we go back to the previous slide, that is we require. So for finding q1 class, we need calculation of 1 by 4 n plus 1. For finding q3 class, we need 3 by 4 n plus 1, because here only require q1 q3, no need of q2. So we will just skip right now. Actually q2 means median. So for finding median, already know we that how to find median class, a class having highest frequency. So this is not required right now. Okay, only we require q1 and q3. So for finding q1, what is the value? Q1 means here already told you 1 by 4 n plus 1. So 1 by 4 n means 2010 plus 1. Okay, so 20 plus 10, plus 1. So you will find, suppose here we have 1, suppose here we have 515. Suppose, so 515 is the value. So we have to check next value of 515 in your cumulative frequency column. So what is the next value? Just after 512, just after value is 855. So this is your Q1 class. Okay. Same way Q3. Q3 is, just see, 3 by 4 n plus 1. 3 by 4 n plus 1. So 2010 plus 1. Suppose we have 1, 2, 6, 4. So we have to check just next value. 1, 2, 4, 6, next value. Next value is this one. 1580. So this is your Q3 class. So Q1 class, Q3 class we have recognized. Next thing is calculation. Q1 means same formula. Qi equal to this one, L plus I n by 4 minus F divide F into C. So this is your Q1 class. So your L value is 40.5. N means 2010 divide by 4. I means 1. I means 1 here. And capital F means cumulative frequency just above of the Q1 class. So which one? This one, 394. So that's why 394 here. Divide F, corresponding frequency is 461. This one into C means difference, that is 40. Same way Q3 class is 120.5, this one, and I equal to 3. So 3 by 2010 divide 4 minus capital F just above of the Q3 class, 1246. You will put here. Divide F, divide is corresponding frequency, this one 334 into C, that is 40. So we got here 49.91, 151.82. So just put the value here, divide by 2. So you will get 50.96. So this is your quartile deviation. Next is absolute mean deviation or mean deviation. Absolute mean deviation, we have two cases. One is simple sample, another one is sample having frequency. Simple sample means only we have x1, x2 dot 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 x1 values there. So mean deviation about A. A means it may be mean, it may be mode, it may be median, whatever it may be. Corresponding this we will find out. So formula is summation I equal to 1 to n xi minus a divide n, where I equal to 1 to 3 up to n. In case of sample having frequencies, just see here, add only the frequency corresponding all the observations. Same thing, mean deviation about A, formula is I equal to 1 to n fi xi minus a divided by sum of fi. Also we can write capital N because we know that sum of frequency and capital N is same. So mean deviation is minimum when taken about the median. So this is important line for short question. Next is question. First we are having an easy question. Find the mean deviation from the mean median mode of the observation 15, 10, 6, 15, 12, 9, 3, 5, 4, 2. So first mean, we are going to find mean. Mean is very easy. Sum of the value divided by number of observation, 8.1. Mean also easy. So first just see, we have to count how many values are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is not possible to find the values of the, because it is not possible to find the middle value. So you have to find out, first we have to rearrange the numbers, then we have to take the middle two value. So after rearranging, middle two value is 6 and 9. So 6 plus 9 divide 2, that is 7.5. This is your median. And mode is, we have to first write all the values, arrange it like this way, 2, 3, 4, 5, this way you have to arrange, and we have to check how many times it is occur. So just see that only 15 occur 2 times, otherwise remaining values only occur single time. So since 15 occur 2 times, so here mode equal to 15. So just see, 15 has maximum frequency 2, so mode equal to 15. So mean, median, mode we require. We got it. Okay. So according to the formula, since this is only having observation, so case 1 here applicable. So what is the formula? Formula is summation of x minus mean divided by number of observation. So here mean equal to 8.1. So summation of x minus 8.1. summation of x minus median, so x minus 7.5, summation of x minus mode, that is x minus 15. So just the value, we need only the sum value of this. So just put the sum value and divide by 10. Why 10? Because number of observations are 10. So in this way, we can find out mean deviation from mean deviation from median, mean deviation from mode. Next question is mean deviation from mean and mode of the following distribution. So just see that in previous case only we have observation. Now we are having observation having frequency. So the second case is applicable. So how do you find the mean? We are going to find mean summation xf by f, this one. How do you find the mode? Just check how many times occur 7 times, so here mode equal to 4. So mean equal to into f divide f, here also into f divide f. So accordingly we will draw the table, accordingly we will arrange the column. Okay, so this one you will check. Ultimately we need the sum value, so accordingly put the sum value and divide by 27, since this is case 2. So here 27 means sum of frequency, so sum of frequency is 27. So in this way we can get to 1.21 and 1.19. Next is mean deviation about median. So in the previous case, we have seen mean deviation about mean and mode. Now here median. So how do you find the median? First, we have to find out the median. So before going to find the mean deviation, so first median means median class we require. Median class means a class having highest frequency. So this is having highest frequency. So this is your median class. So just use the formula of median. We got 17.86. Okay, so the according to the formula, how do you find the formula? Summation xi minus, since here median, so here a equal to 17.86 into f divide sum of frequency. So into f means here the corresponding frequency, this one, and the sum of frequency. So we will find 10.41. Next is standard deviation. So we have two types of standard deviation, one in case of simple sample, another in case of sample having frequency. So this is the formula, we can denote it by sigma. So root under summation I equal to 1 to n xi squared by n minus summation xi to xi I equal to 1 to n xi by n whole square. And having frequency, just here we will add the frequency, if I xi squared by n and if I xi whole squared by n. And keep in mind here small n, this is number of observation, here's capital, that is sum of frequency. Next, a note is required, that is standard deviation is always taken as a positive quantity, and the square of standard deviation is called variance of the distribution, and var x equal to s square sigma square. And so standard deviation is, or sigma we can write, positive square root of variance is called standard deviation. And find the standard deviation of the observation. Here only observations are there, so we should apply here the first case. This is the summation of summation xi square by n minus summation xi by n whole square. Accordingly we will find the value, and the formal value is 3.16. Next is find the standard deviation of the distribution, where x equal to 1, 2, 3, 4, 5, 6 and corresponding frequencies are there. So here we have to apply the second case, and here is the formula. Keep in mind here we are going to find observation as well as the frequency. So here formula 2 is applicable. So accordingly we will find the value, and the value is 1.74. Next is some important deduction. So here first is the theorem. Number one theorem is a standard deviation is independent of the range of the change of origin, but depend on the change of scale. So here let x1, x2, x3 up to xn be n simple observations, and let y1, y2, y3 up to yn be another set of observation, such that yi equal to xi minus c by d, where I equal to 1 to dot 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 n, where change of origin and change of scale have been applied, c and d being two constant, that is sx equal to modulus of d sy. Okay, but that means we will take the positive distance. And here another theorem is we have, if n1 sigma 1 and x1 bar be the number of observation, standard deviation and mean of a set of observation respectively, and n2 sigma 2 x2 bar be those of a second set of observation, then if sigma be the standard deviation of the combined set of n1 plus n2 observation, then we can write n1 plus n2 sigma square equal to n1 sigma 1 square, n2 sigma 2 square plus n1 d1 square plus n2 d2 square. So where d1 equal to x1 bar minus m, d2 equal to x2 bar minus m, and this is the combined mean m equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So we can write n sigma square equal to n1 sigma 1 square plus n2 sigma 2 square plus n1 n2 by capital N into x1 bar minus x2 bar whole square. And keep in mind, n means sum of frequencies, that is also we can write n1 plus n2, that is number of observations. Okay. So now one example regarding this. Calculate the standard deviation of the following distribution. So keep in mind, in the first case where we found the standard deviation, in the first problem was where we have only observation. Second problem was observation having frequency, but in this problem we have class interval having frequency. So when the class interval is involved, we have to use the change of scale property. That means we have to apply the formula yi equal to xi minus c by d. So here class interval we have, frequency we have. Next is just see here. So here class interval, after this, so we are having class mark. So just 10 plus 19 by 2, that is 14.5, 20 plus 29 by 2, 24.5. Here I have skipped one column, that is class boundary. You have to add the column whenever you will practice at the your on your copy. So you must add one more column, that is class boundary. Okay. So here next is y equal to yi equal to xi minus c by d. So just see that here c equal to, so since c, how do you find the c? Already I told you. So we have to check how many points are there, 1 2 3 4 5 6. So between just among the 6 point, these two are middle. So between these two middle, so you will take the higher value, that is 44.5, and divide by 10, that is after class interval, after class boundary, you will find 9.5 to 19.5. So on that scenario you will find here d equal to 10. So that's why I've written here 10. I've skipped here one column, that is class boundary. Again I repeat, whenever you will practice on your copy, you have must add one column, that is class boundary. Okay. So y equal to xi x minus 44.5 divide 10, why 10? That's why here 10. Here difference is 10. And next is yf, y square and y square f. So first we have to find with respect to y, then with the help of the formula you will find x. Actually your standard deviation, with the calculation, you have to find in terms of x, not in terms of y. So first we have to find in terms of y, then we have to go back to in terms of x. So we have to find first sy. So this is your sy. Actual formula is x equal to, according to the property 1, x equal to modulus d sy. So here you will put the value. So x equal to modulus d sy. Modulus d means 10. So 10 into sy already we found 1.356. So you will find 13.56. And the next is the mean of two groups of 40 and 50 observations are 90 and 80 respectively, and their corresponding standard deviations are 4.1 and 3.9. Find the mean and standard deviation of the combined 90 observation. So using the formula, which formula? Just see the combined mean, just we have done here, n1 x1 bar plus n2 x2 bar divided by n1 plus n2. So here the combined mean, this one equal to, so here first observation is 40, just n1 into x1 bar. So here so n1 means here, so here n1 means 40, and here x1 bar plus n2 means here 50, and x1 bar means here 90, and x2 bar here 80, and divide by n1 plus n2, that is 40 plus 50, so 84.44. Next, using the formula n sigma square equal to n1 sigma square plus n2 sigma 2 square plus n1 by n2 divided by capital N. Just use the formula, you will find here capital N equal to 40 plus 50. N1 means here 40. Sigma 1 square is 4.1 whole square. N2 means 50. sigma 2 square means 3.9 whole square, and put the value. Accordingly, you will find sigma equal to 6.37. Okay. So next is find the mean, median, standard deviation and mean deviation about the mean from for the following data. So in this problem, we have to find all together, that is mean, median, standard deviation and mean deviation about the mean for the following data. Mean means already just see that here class interval is present, corresponding the frequency is present. So definitely here we will use change of scale property. So change of scale property in mean and change of scale property also in standard deviation. So here, so class interval, since again here I have skipped one column, that is class boundary. You must be find out class boundary, class mark, frequency. This is yi column, yf, y square f, modulus of x minus x bar, modulus of x minus x bar into f. So first we have to fix the formula. According all the formula, we have to fix the column, because without knowing the formula we are unable to implement the column. So first we have to know the all the formula correctly, then according to the formula you will implement all the columns. Okay, accordingly you will apply the change of scale property. So then you will find out, you will able to find out mean, median, standard deviation and the mean deviation about the mean correspondingly. Okay, so this way we can find out mean, median, standard deviation and the mean deviation about mean from a single table. Okay, so here same formula, yi equal to xi minus c by d. So y here c means, again just see here 1 2 3 4 5 6, again we have here 8.5 and 10.5. Okay, so here one question will arise, why I have written here 8.5, why not 10.5? Actually students, we can use 10.5, that is our opinion, because this is the maximum value. Also we can use another value, that is 8.5. If somebody will write 8.5, also he or she will correct. Okay, so no confusion here, you can take either 10.5 or you can take 8.5. So by suggestion always you will use the higher value. Okay, and if you use the 8.5, so your answer may be differ, not maybe, must differ. Okay, little bit 0.001 or 0.002 point will be differ, but my suggestion you will take the 10.5. I have taken here 8.5, that is also okay, but my suggestion you will take 10.5. Okay, so in this way we can find out first mean, that is mean. After getting the mean, you can also find mean deviation from the mean, that is the second part, this one. Okay, then we can easily find the median. How do you find the median? Just here, if you want to, I'm not finding here median. If you are going to find median, one column will be extra, that is cumulative frequency, because we know that for median cumulative frequency only one column is required. Okay, next is standard deviation. Standard deviation is same thing here, class interval is there. So we have to find out first with respect to y, then with respect to x. Okay, that means change of scale property is applicable. So one sentence is very important. When the class interval is present, it may be for finding mean or it may be for finding standard deviation, change of scale property required. Okay, so this is way we can find out mean, median, standard deviation and mean deviation about the mean. Okay, so this is the value, that is, and the end standard deviation is equal to 2.48. Okay, so this is the class, and so this is enough for measure of dispersion. Okay, in next class we will find we will use we will go for another chapter. Okay, so till then, bye bye all of you.